The other basic type of structure within scripting is called the loop, and the loop is also a flow control kind of operation, but it will just repeat certain operations a set number of times. And we're going to use the loop here to basically do the same operation for any number of elements. So if you remember here, we had 840 surfaces coming in. We basically want to make this code where for each surface, it gets baked and the side material, and then that will keep happening over and over for all 840 surfaces. So to do that, we can loop over basically all of the surfaces in that list. The first thing we'll need is some way of getting the length of that list. In Python, that is the length function. So just to see how this looks, we can print something out just as a tester. Say print the length, so length is len, and our list coming in is called geo, right? So we're going to say print len, and then anytime you do a function, its inputs you put into the parentheses. Okay, so now we print out 840. That's the length of our list. And we're going to use this length to build up a loop. And loops are structured using this syntax. We say for some element in some list of elements. We say for I, and this is just a variable. And here we need basically an index into every part of that list. So we'll type range length geo. Just to show you again, I'll just print range of length geo. It's going to create one number for every index up to that maximum length. Okay, so this will give us an index basically to get every piece of geometry, every surface, one after the other. So now if we set up this loop, we say for I in range length, and then colon, and hit enter. You can see it indents one more time, and now we have a kind of sub piece of code that will loop over and over for this many times. And here, if we print I, hit test, you can see it's basically looping this number of times, and within each loop, I takes on the value of the current index. Okay, so this is just a basic setup where we can have an index to reference each piece of that geometry. All right, so that's the basic setup of the structure of our code. Basically, we have a conditional saying whether the code will execute, and we have a loop setup that will loop over every instance of our geometry and will give us I as the index of that geometry in the list. And now I'm just going to type in a series of commands to basically reference the geometry that we want from Grasshopper, bake it, and then assign the material. I'm just going to go through all these commands. You can follow along. But again, like the way to figure out what commands you really need is you have to go to the reference of the API and the Python. Okay, so the first thing I'm going to do is change the script context so we have access to the Grasshopper document. And for that, I'll type in script context.doc equals ghdoc. And this will tell Python that we want to work within Grasshopper now. The next thing I'll do is I'll create a reference to the specific surface that we want from this list. So I'll create a new variable called geoid, and I'll set that equal to our geo. Geo is the list of surfaces, and then to get a specific item within that list, we just pass it the index. This is just like when in Grasshopper we use list index and we pass it like an index into that list. We can use I here to get a specific surface. So the first time this loop runs, I will be 0, and it's going to get the first surface in the geo list. The second time it'll be 1, it'll get the second surface from the geo list, and it'll put it into this variable, and we're going to work with this variable to basically work with that surface. Okay, so once we have the geometry reference, we're going to actually get that surface from Grasshopper itself. So this right now is just kind of a reference to it. If we print this geoid, I'll show you what happens. So we'll run this. You can see that now it's gone through all the surfaces, and it's given us back this reference. But this is just a unique identifier. This is how Rhino and Grasshopper identifies geometry within its interface. to start working with the surfaces, we actually have to convert that ID into the geometry itself. And we'll do that by creating another variable. And then here we use our Rhino script syntax command. We type in rs.coerce Rhino object, and we'll pass it in the geometry identifier. Okay, so coerce Rhino object is a command within Rhino script syntax, which will take this GeoID, which is like a numerical reference to the object, and it's going to give us this actual object. So doc object will actually be that surface. So here, if we print doc object now, you see we actually get that surface. This is Rhino geometry brep, and it contains both the object reference and its attributes. This is what we want. So basically, this series of steps is just a way to go from what's being input here into the geo node to an actual object that we can now work with. Okay, so it's a little bit complicated, but it's a basic kind of process that you have to take whenever you import geometry into the script. All right, so now once we have that object, we're going to create references to both the geometry of the object and its attributes from Grasshopper. We'll create a variable called attributes doc object. So remember, doc object is now our surface. Dot attributes. And now this is a reference to the attributes of the object. We're going to do the same thing for the geometry. We're going to create a variable called geometry equals doc object dot geometry. So now if we print the attributes, you can see that this is just a reference to the attributes, or like the parameters of that geometry. And if we print the geometry, this is a reference to the brep itself, so the actual surface definition. So now we have everything we need basically to reference that geometry, and now we can bake it into the Rhino interface. So the first thing we need to do is change the script context. So in here, we're always working with the Grasshopper document because we specified Grasshopper document as the script context. Now we need to change it to reference the Rhino document in order to actually bake that geometry. And baking is basically creating objects within Rhino. Okay, so to access Rhino itself, we just type in script context.doc. So this is the same as what we did before. Equals, this time we'll say Rhino doc active doc. Okay, so this is just a reference to the Rhino document that's active in our view. Okay, so it's going to literally now be able to work with this document. So once we have our context, we can bake the geometry that we have referenced here into the Rhino document. So to do that, we'll type in script context. Oops, sorry, it has to be all lowercase. Script context dot doc. So here we're referencing the script context that we just specified. Dot objects dot add. And this is a basic structure for adding geometry into a Rhino document. So you can think of this as the scripting version of baking. So anytime we want to bake something from Grasshopper, we're just making geometry in Rhino. And here we'll pass a few parameters. So we type open parentheses. And we're going to pass it the geometry of our surface. So from here, where we specified it. And also the attributes of those surfaces. Okay? And this will basically go through and create each surface within Rhino. So just to make sure this is working, if we hit test now, you can see it's actually baked all of those surfaces one at a time into the Rhino document. Okay, so this is where you have to start to be careful. If you don't want this to execute every time, you have to put this to false. So now we can take a look. If we hide the Grasshopper geometry, you can see it's actually baked all of those surfaces right into the Rhino file. Okay, and that's just one implementation. You can see the power of this is that actually through just a few lines of code, we're able to work directly with the Grasshopper document and also with the Rhino document just by switching the context. Okay, so I'm going to delete all the surfaces for now. We'll get back to this code. I'm going to keep this at false, so when we're testing things, it doesn't keep rebuilding those surfaces.